Alrighty, so in this section, we are going to be talking about factoring. So we talked about the greatest common factor, and that is a great step to always start when you're doing any sort of factoring. You should always start off by looking for a greatest common factor if that's something you can pull out in front. Now we're going to get into more of the factoring where we're going to end up with two binomials. So the way I like to do factoring is using the box method that we used with multiplying, but now we're going to use it in the opposite direction. So we are now going to make a 2x2 box like we did before, and we're going to fill in what we know. So we know the stuff that's inside of the box this time, and we need to find out what's going to be at the top and on the side of our box to see what they multiply together to get this trinomial. So we know that they got x squared, and over here they got a positive 6 as their constant, and we also know that their diagonals added to be a positive 5x. So I have to ask myself, what two things would go here and here to multiply to become x squared? So that would be an x times an x would multiply to become an x squared. Now, this is where you have to think about the other two places that we need to fill in and how the 5x and the positive 6 work together to get that magic trinomial that we're trying to find. So, whenever you're doing this, you want to figure out things that multiply to be 6. What multiplies to be 6? Well, we could have, and it's going to be a positive 6. So in order to get a positive 6, we could multiply a positive times a positive or a negative times a negative. So a positive 1 times a positive 6 could give us positive 6, or a negative 1 times a negative 6 could give us a positive 6. We could also do a positive 2 times a positive 3, or a negative 2 times a negative 3. So all of these are options in order to get us to what we need in that trinomial. Now, let's try out one of the options. So if I notice right off the bat that I'm not going to need any negatives. There was no negatives in my trinomial whatsoever, so I'm going to cross off those negative options. They're not going to work. So I'm going to try the 1 and the 6. So if I put in 1 and 6 on the top and the side, 1 times x would give me a positive 1x. And 6 times x would give me a 6x. Now, if I check this, a 1x plus a 6x is not going to give me that 5x. So I'm going to go back and try again. I know that this option did not work, so I'm going to cross that off my options, which is going to leave me with the 2 and the 3. So hopefully this works. 3 times x is going to give me the 3x. And 2 times x is going to give me the 2x. And I got to check this. 3x plus 2x does give me that 5x that I needed. So I know that my answer on the top and the side is correct. So I'm going to write my answer, which is a x plus 2 because it was a positive 2. And an x plus 3 because it was a positive 3. So again, if I were to multiply those back out, I should end up with that trinomial that I started with in the beginning. You can always check your answer. Now, if you want to try out some problems on your own, why don't you press pause right now and try the next 4 problems, A, B, C, and D, and see how you do, and we'll check it in a second. Okay, now that you tried those, let's make sure you did okay. So I'm going to make my box, and I'm going to fill in everything that I know. So I know that we are going to be an x squared right there. And our constant was a positive 36. And those diagonals are going to add to be a positive 13x. So I got to figure out what multiplies to be a positive 36. So that could be 1 and 36, negative 1 and negative 36. We could also have a 2 and an 18, or a negative 2 and a negative 18. We could have 3 and 12, or negative 3 and negative 12. We could have 4 and 9, or negative 4 and negative 9. And that looks like, oh, we could also have 6 and 6, or negative 6 and negative 6. So we have a lot of options that we could go with here. So I noticed right off the bat, I have all positives in there, so I'm going to get rid of all those negative options because I don't really need them. I just need positives for this one. Now, if you have noticed, there is a pattern with this. So if you did notice it, way to go. But I'm going to try, so I need to figure out, first off, that I need to multiply to be x squared. So in order to get x squared, I would have to have an x and an x. That would multiply to become x squared. And I'm going to just try one random option. Let's try 3 and 12. So 3 times x is going to give me 3x. And 12 times x is going to give me 12x. So if I try that out, 12x plus 3x will give me 15x, which is not going to work. So I need to try another option. So let's erase this and try a different one. So I'm going to cross off that 3 and 12 on my list. It didn't work. Let's go down the list. Let's try 4 and 9. 4 times x will give me 4x, and 9 times x will give me 9x. So if I check that, 9x plus a 4x does give me 13x. So I got this right. So I can see that my solution is what I found on the top and the side. So my answer is an x and a positive 4, and an x and a positive 9. Alrighty, let's look at the next example. We have to make our box, and we want to get an x squared, a positive 28, and we want our diagonals to add to be a positive 11x. So let's figure out what's going to multiply to be 28. So we could have 1 times 28, negative 1 times negative 28, 2 times 14, negative 2 times negative 14, 4 times 7, or negative 4 times a negative 7. So first off, what multiplies to be x squared would be an x and an x. And then we need to figure out which one of these would work. Negatives, again, are not going to work because we don't have any negatives in our trinomial. And I like to start somewhere in the, let's start at the bottom this time. Let's try the 4 and the 7. 4 times x is going to give me 4x. 7 times x is going to give me 7x. And then if I check this, 4x plus a 7x does give me 11x. So my answers are x plus 7 and x plus 4. Make sure you're writing your answers how I'm writing my answers in the parentheses, just like mine. Okay, next example, we had to be x squared again. with a positive 7x, and our diagonals needed to add to be a positive 8x. So we need to figure out what multiplies to be positive 7. Well, that would be 1 times 7 or negative 1 times negative 7. Not too many options on that one. So let's figure out our sides and our top. So x squared would be an x times an x. And I kind of know that it's not going to be that negatives because we don't have any negatives. So it's probably going to be 1 and 7. Let's try. 1 times x would be 1x. And a 7 times x would be a 7x. And 7x plus a 1x does add to be 8x. So I have my solution. That x plus 1 and that x plus 7. Okay, last example of these, we are doing the same thing. X squared, we need to be a positive 2, multiply to be a positive 2. Oops. And those diagonals have to add to be a positive 3x. So what's going to multiply to be positive 2? Well, 1 times 2. Or negative 1 times negative 2. Not too many options on that one. So negatives probably aren't going to work. But let's figure out x squared would be an x times an x becomes x squared. And in order to figure this out, it looks like we're left with the 1 and the 2. Let's see if it works. 2 times x is a 2x. A 1 times an x is a 1x. And a 2x plus a 1x does equal 3x, so we have our answer. X plus 1 and an x plus 2. If you're wondering, is there an order that I have to write these in? No. You could also write this as an x plus 2 and an x plus 1. The order does not matter. You can decide. What does matter is your number and your sign. You got to make sure you have the correct sign because it could be a negative or a positive. Okay, trying the next example. Same process as what we have been doing, but now it looks like we're adding some negatives in there. So let's try this one out. We need to multiply to be x squared and multiply to be positive 18 with the diagonals adding to be a negative 11x. So let's think about what is going to multiply to be positive 18. 1 times 18 could work. Negative 1 times negative 18. 2 times 9 or negative 2 times negative 9. 3 times 6 or negative 3 times negative 6. So we got a lot of options here. I know that for sure since we have that negative in the middle, that's what our diagonals need to be. I don't think these positives are going to work. We're going to need negatives this time. So we need to start off by figuring out what multiplies to be x squared, which we know would be x times x. And then I need to figure out which one of these options is going to be the best fit. So if I try, let's try negative 3 and negative 6. So negative 6 times x would be negative 6x. Negative 3 times x is negative 3x. And if I check this on my calculator, a negative 3 plus a negative 6 is not going to add to be negative 11. It's going to give me negative 9. So this option did not work. So we got to try another one. I'm going to cross that one off. Let's try negative 2 and negative 9. So negative 9 times x is going to give me negative 9x. Negative 2 times x is going to give me negative 2x. Then if I check this, negative 2x plus a negative 9x does give me negative 11x. So I have my answer, x minus 9 and x minus 2. Okay, if you want to pause here and try some examples on your own, go ahead and do so now. Okay, now that you've tried those examples on your own, let's see how you did. So on the first one, we have to multiply to be x squared, multiply to be positive 15, and our diagonal needs to add to be a negative 8x. So you had a bunch of options: 1 times 15, negative 1 times negative 15, 3 times 5, or negative 3 times 5. Not too many, not too bad. So x squared is x times x. And then you should have gotten the negative 3 and the negative 5 when you put them in there and multiply it out. Do add to give you that negative 8x. Alrighty, looking at B, we got to fill out our box again. Multiply to be x squared, multiply to be 42, and our diagonals need to add to be a negative 13x. So when I figure out my multiples, there is a fair amount. 1 times 42, negative 1 times negative 42, because we're multiplying to be that positive. We could have 2 times 21, negative 2 times negative 21, 3 times 14, negative 3 times negative 14, or 6 times 7, negative 6 times negative 7. So a bunch of options here. What multiplies to be x squared? Well, that would be x and x. And then once you get down to it, you should have figured out that your answer was a negative 6 and a negative 7. So that when you put it in there, negative 6x and negative 7x, add to be that negative 13x that you were looking for. Oh, I did not write my answer on my last one. Let's write our answers for both of these. We should have had on A, x minus 5 and x minus 3. And on B, we should have had x minus 6 and x minus 7. Okay, now that you've done these two, let's go over it and see how you did. On this one, we should have had x squared here, a positive 9x here, and our diagonals should be adding to be a negative 10x. So when we're figuring out our multiples, 1 times 9 or negative 1 times negative 9. We could have 3 times 3 or negative 3 times negative 3. So x squared is going to be that x. Sorry. X times x. And then you should have gotten negative 1 and negative 9 to be what works, because that gives you a negative 1x plus a negative 9x adds to be that negative 10. So if we write our answer from the top and the side, we have an x minus 1 and an x minus 9. Last example in this section, we have our box set up, x squared, a positive 10x, and our diagonals we're supposed to add to be a negative 11x. So our multiples of 10, 1 times 10, or negative 1 times negative 10, 2 times 5, or negative 2 times negative 5. So when I go to figure this out, multiplies to be x squared was that x and x. And your answer should have been a negative 1 and a negative 10, because that gives you a negative 10x plus a negative 1x, giving you that negative 11x that you needed. So our answer should have been an x minus 1 and an x minus 10. All right, looking at example 3, we're doing the same process again. Nothing's changed, but we're just still changing around where our positives and negatives are. Okay, so if we make our table, we need to multiply to be that x squared. This time we're multiplying to be a negative 6, and our diagonal has to add to be a positive 5x. So if I figure out what multiplies to be a negative 6, so this is where your options are super important. We could have a 1 times negative 6 or a negative 1 times a positive 6. Those would both multiply to give me negative 6. Or we could have a positive 2 times negative 3 or a negative 2 times a positive 3. These may seem like the same thing, but they will make a difference, and you have to be super careful when you're putting them into your box on where they go and which one gives you the right answer. So let's try this out. What multiplies to be x squared? Well, that's still going to be x and x. But now we need to become a positive 5x. So it could be any of these. Let's just try one. So let's start with the top one. Negative 6 and a positive 1. So negative 6 times x would give me a negative 6x. And a 1 times x would give me a 1x. So if I try this out, 1x plus a negative 6x is going to give me a negative 5x. Super close, but not what I'm looking for. So this first option did not work. I'm going to cross that one off, and I'm going to go to the second one. Let's try that negative 1 and positive 6 this time. So negative 1 times x gives me a negative 1x, and 6 times x gives me a 6x. So let's try 6x plus a negative 1x does give me that positive 5x that I'm looking for. So I found my answer right here, x minus 1 and an x plus 6. Notice that was super close to my first option that I tried, but it did not give me the correct signs. So I had to change my option and see which one worked. So if you want to pause here and try the next couple examples the same way, do so now. Alrighty, so let's try this first example. We are making our box, and we need to have an x squared, a negative 14, and our diagonal this time has to add to be a negative 5x. So when we figure out our multiples, we could have a 1 times negative 14 or negative 1 times positive 14. We could have 2 times negative 7 or negative 2 times positive 7. So now that we have all of our options, x squared is going to be that x times x still. And now we just have to kind of go down the list and see which one works the best. So let's try, I'm not loving the ones with 14. Let's try a 2 and a 7. So let's try 2 and negative 7 and see if that works. Negative 7 times x is a negative 7x. And a 2 times an x is a 2x. So if I check that, 2x plus a negative 7x does give me negative 5x. So I found it right off the bat. So my answer is x minus 7 and x plus 2. Okay, example B. When you made your box, you should have had x squared up here, a negative 16 down there, and your diagonals adding to be a positive 6x. So we had a couple options. We could have had 1 times negative 16 or negative 1 times positive 16. We could have a negative 2 times positive 8 or a 2 times negative 8. Or we could have 4 times negative 4. Now if I flip that around, it would be exactly the same thing. So I don't have to write that one twice. So x squared is going to be that x and x. And then we gotta try some options. Let's try, I'm gonna go in the middle. Let's try -2 and +8. -2 times x is -2x. 8 times x is 8x. And if I check that, 8x plus a -2x does give me my +6x. So I found my answer, x plus 8 and x minus 2. Now remember, you could be writing this in either order. X minus 2, x plus 8 is the exact same thing as what I wrote. It does not matter which order, as long as that negative and positive is still with the correct number. Same thing on example A. You could have written x plus 2 and x minus 7. That's still correct. Okay, let's try these examples, see how you did. So let's go and make our box. We need to have that x squared up in the top. And we need that -24. And then our diagonals on this one, we're adding to be a +2x. So we got to figure out our multiples for this one. So I need to multiply to be a -24. So we could have +1 times -24. We could have -1 times +24. We could have 2 times -12 or -2 times +12. We could also have 3 times -8 or -3 times +8, as well as a 4 times -6 or -4 times +6. So a fair amount of options on this one. X times x is still going to give us that x squared. And after you tried a couple options, you should have come across that 6 and -4 give you a 6x and a -4x, which do add to be 2x. So your answer on this one should have been x plus 6 and x minus 4. Or you could write it the other way, x minus 4 and x plus 6 is the same answer. Okay, last example on this one, set up your box, x squared, a -56, and your diagonal should have added to be a -1x. If you want to add that 1 in there to help you out, that's fine. Alrighty, so our multiples of 56 or -56 could be 1 times -56, -1 times +56, 2 times -28, or the other way around. We could also have 4 and -14, or -14, 4 and 14. We could have 7 times -8, or -7 times +8. A fair amount of options, but once you tried it out, you should have x and x. And then your winning numbers should have been a +7 and a -8. Because when you add it out, you should get a -8x plus a 7x, which does give you the -1x that you needed. So your answers should have been x plus 7 and x minus 8. Or remember, you can put it the other way around and it should be the same thing. Okay, last examples. There was a fair amount on this section. We need to have an x squared with a +8x, and your diagonals should have added to be a -6x. So on this one, we got to multiply to be a positive this time. Be careful. So you have a 1 times 8, or a -1 times -8. 2 times 4, or a -2 times -4. So When you try it out, you should have come across that -2 and -4 are the winning numbers because it should be a -4x plus a -2x that adds to give you -6x. So your answer should have been x minus 2 and x minus 4, or x minus 4 and x minus 2. Either one is perfectly fine. Last example in this section, we have an x squared up here with a multiplying to be +8 and our diagonals adding to be a +6x. So our options again for +8 are just like the last one. Nothing's changing except for which one's gonna work. Because this time we want to add to be a +6x instead of -6x. So if you try it out, it ends up working with a 2 and a 4 because 2x plus 4x become 6x. So your answer is x plus 4 and x plus 2, or the other way around, x plus 2 and x plus 4. Either one is perfectly fine.